Now let's discuss the rule for differentiating a quotient of two functions. Suppose, for instance, you are given functions t of x and b of x to be two differentiable functions where t of x represents the top function and b of x represents the bottom function. So if f of x is equal to t of x divided by b of x, and if t prime of x and b prime of x exist, then the derivative of this function is given by this formula here. So note that the derivative of a quotient of two functions is not equal to the quotient of their derivatives, but rather equal to the bottom function times the derivative of the top function minus top times the derivative of the bottom divided by the bottom squared. Or it could also be helpful to think of it this way. Instead of top over bottom, you could think of this as your high and this is your low. So instead, you would say low, so the low function, d high, that means the derivative of the top function, minus high, the one in the numerator, d low, derivative of the bottom, all over low squared. Now to differentiate the quotient rule, let's consider the following function and find the derivative. The derivative of a quotient is given by low d high minus high d low all over low squared. So that means f prime of x using this formula means low, you copy the bottom, d high, derivative of the numerator, x squared prime, minus high, copy the numerator, d low, differentiate the denominator, 2x minus 1, divided by low squared. Now simplifying this, we have 2x minus 1 times derivative of x squared is 2x minus, copy x squared, times the derivative of 2x, which is 2, divided by low squared, 2x minus 1 squared. And then you can simplify the numerator by expanding this, distributing 2x to each term in the parentheses, and same here too, and then combine similar terms. So distributing 2x inside the parentheses, you have 2x squared minus 2x, and 2 times x squared is minus 2x squared, divided by 2x minus 1 quantity squared. Now 2x squared minus 2x squared is equal to 0. So this is just equal to negative 2x divided by 2x minus 1 squared. Now same as before, when doing your homework, you may input your answer like this, and MyMathLab would accept that. Now to illustrate this, let us consider the following homework. Use the quotient rule to find the derivative of the given function. To do this, we are going to use the formula for the derivative as y prime is equal to low d high minus high d low all over low squared. Low means you copy the denominator, so you have x plus 7 times d high means the derivative of the numerator, x squared minus 9x plus 1 prime minus high, so we copy the numerator, x squared minus 9x plus 1 times the low, derivative of the denominator, divided by low squared. Okay, and then we'll go ahead and perform the derivatives here. So we have x plus 7 times the derivative of x squared minus 9x plus 1 is equal to 2x. The derivative of x squared is 2x minus the derivative of 9x is 9. So you have negative 9. Minus, and then you copy the expression here, x squared minus 9x plus 1 times the derivative of 7 plus x plus 7 is 1, divided by x plus 7 squared. Now instead of expanding this, let's go ahead and try to plug in our answer like this. Now using the computation here, we will input our answer for the derivative of this function as is. So we have fraction, and then let's input this. So we have the quantity, so that's of the numerator, quantity x plus 7 times quantity 2x minus 9 minus quantity x squared minus 9x plus 1 close parenthesis times 1. You don't need actually to write that times 1 there. And then divided by x plus 7 quantity squared. Right, and then you check your answer. As you can see, MyMathLab accepts answers even if it's not in its simplest form. Now let's consider another example. Find the derivative of this function. So we will use y prime equal to low d high minus high d low all over low squared. So low means the denominator times d high, the derivative of the numerator, minus high, so that's t squared minus t, times the low, t cubed plus 1 prime, divided by t cubed plus 1 squared. Then let's perform the derivative here. So we have t cubed plus 1 times the derivative of t squared is 2t, and the derivative of t is 1, minus, copy this factor, t squared minus t times the derivative of this. Derivative of t cubed is 3t squared, and the derivative of 1 is 0, divided by the square of the denominator. Okay, and then we'll leave our answer like this. Find the derivative for the function f of x equal to 2x over x squared plus 3. F prime of x is equal to low, so that's x squared plus 3, d high, derivative of 2x prime, minus high, 2x, times the derivative of the denominator, d low, x squared plus 3 prime, divided by low squared, x squared plus 3 squared. Then let's go ahead and perform the derivatives here. So we have x squared plus 3 times the derivative of 2x is 2, minus 2x times the derivative of x squared plus 3, which is 2x, divided by, copy the denominator, x squared plus 3 squared. Now, in answering your homework, you can plug in your answer like this, or you can also simplify it. So when simplifying this, you just distribute 2 to each term in the parentheses, and then here as well, and then combine similar terms. So we have 2x squared plus 6 minus 4x squared divided by x squared plus 3 squared. 2x squared minus 4x squared is negative 2x squared plus 6 all over x squared plus 3 squared. And that's the derivative. So for the next example here, we are to find the derivative of the function here in two ways. That means we will differentiate it using the techniques that we have learned so far. So probably the most obvious one is to use the quotient rule. So let's use the quotient rule. So using the quotient rule, we find the derivative y prime, which is equal to low x squared cube, the high 2 plus x cubed prime minus high 2 plus x cubed, the low x cubed prime, divided by x cubed squared. And then simplifying this, we have x cubed times the derivative of this is 0, and the derivative of x cubed is 3x squared, minus, copy 2 plus x cubed times the derivative of x cubed, which is 3x squared, divided by x to the 6. Now, when simplifying this, you have 3x to the 5th minus, and then you distribute this to each term inside the parentheses. So minus 6x squared minus 3x to the 5th divided by x to the 6. Now 3x to the 5th and this negative 3x to the 5th cancels out. Therefore, we have negative 6x squared over x to the 6, which you can further simplify. You can cancel x squared. That gives you negative 6x to the 4th. Now for the second way, or another way of differentiating this function, is to rewrite the given function and then use the technique that we learned at the beginning of this chapter. So first step is to divide each term by x cubed. So you have 2 plus x cubed over x cubed will be equal to, then you divide each term. So this will be equal to 2 over x cubed plus x cubed divided by x cubed is 1. Now, this one, in order to differentiate this, we can use the power rule. We need to rewrite this expression first as 2x to the negative 3 plus 1. Then after that, you can now go ahead and differentiate. So y prime will then be equal to, you multiply 2 and negative 3, that is negative 6. X to the, and then subtract 1 from the power here, negative 4. And the derivative of 1 is 0. Now, upon simplifying this is just equal to negative 6 over x to the 4th, which is the same as what we got using the quotient rule. Therefore, this means that whichever method you use to differentiate this expression here will yield to the same result.